that contain general solution.
This one.
Yeah.
Yeah. You happy with this now?
Yeah, I got it already.
Good. Right. So let's see the next question. Is the sound clear? My voice is clear?
Yes.
Yeah, I can hear you.
Is there any delay when I'm writing or no? I don't know.
No, a little bit.
Oh, that's great. Okay. Find the general solution to the differential equation dy over dx equals 2y plus 3. Okay, so find the general solution. At the moment, they didn't give us any value of x and y. If it's given, you will use it at the end of the question. So for now, just the general solution. So as you can see here, we have dy over dx and 2y plus 3, the other side. So first of all, we need to separate, make the x's in one side and the y's in the other side. So in this one here, we don't have x's actually, yeah? We have 2y plus 3. So what we will do, we will divide by 2y plus 3. I can't separate this one here, right? So this will be dy over 2y plus 3. Okay, well, over dx. Over dx, and this like multiplied by 1 over 2y plus 3 equals, well, I'm going to multiply both sides by dx as well. So there's going to be dx here and this dx here, so they will cancel each other. So basically, I put the dx in one side and the dy in the other side. So now we will integrate. So this is going to be the integration. Change the color maybe better for you. The integration of dy over 2y plus 3 equals the integration of dx. Okay. So when we integrate, okay, here it is. Is it this thing? Yeah. So we have it now 1 over 2y plus 3 dy equals dx. Then we integrate. The integration of the dx is x plus c, right? And the integration of 1 over 2y plus 3 is 1/2 ln 2y plus 3. Do you know why? Do you know why it's ln 2y plus 3? Yes or no? Because if you remember the function of the integration of f prime x, or f dash you call it maybe some of you, over fx dx equals ln f of x. Yeah, and divided by the derivative of x as well, if there is any. So in this case here, we have 1 over 2y plus 3. What's the derivative of 2y plus 3? Anyone can answer me quickly? What's the derivative of 2y plus 3?
1 over
2.
What's the derivative of 2y plus 3?
2.
2, yeah? So if we have 2 here, if we have 2 here, it will be immediately we can say this is ln 2y plus 3. Yes? If we have the 2, but we don't have the 2. We have 1 over 2y plus 3. So to be able to write it down as ln 2y plus 3, it's like we multiplied by 2, but we can't, because this is like, it's a term, we can't just change as we like. So it's like we multiply by 2 and we divide by 2. Okay? Then in that case, we can say it is ln 2y plus 3. and then we divide by the derivative of the inside, which is 2, yeah? So that means multiplied by 1/2. And then when we simplify, we will get this 2 go with this 2, and we end up with 1/2 ln 2y plus 3. Okay? 1/2 ln 2y plus 3. So equals x plus c. And then from this, we rearrange until we get the y. Okay, let me show you how to get that. Just a minute. Where is it? Y equals, I worked it out earlier. Y equals, yeah. So let's start from, I need a space really somewhere. I'll just show you here, okay? What? I have the whiteboard. That's why I'm using the whiteboard really. Okay, so let's say from the step of half, what is it? Half length. What I want to show you, I really forgot now what I want to show you. I want, okay. Right, I want to show you like ln e to the power y, yes, equals, no, I'm just a question, sorry, that's fine. Okay. So from this step, I would write half ln 2y plus 3 equals x plus 3. Okay. So from this step here, this circle here, from this step, I'm going to write on the board. So it's half ln 2y plus 3 equals x plus c. So to carry on with this, to simplify it, we can write it down as we multiply both sides by 2, okay, to get rid of the half. So this is going to be ln 2y plus 3 equals 2x plus 2c, okay? So this 2c, it's basically, what is that? It's a constant, so it doesn't matter. We can call it like G or just capital C, just leave it as C, it doesn't matter, right? Or K. Then, now to get rid of the ln, we can take e to both sides, or we can use the definition of the ln, yeah? If we have ln 2y plus 3, that means ln to base e equals 2x plus 2c or c. That means we use the definition. We can use the definition or take e for both sides. So anyway, the e will cancel the ln. So e to the power ln 2y plus 3 equals e to the power 2x plus 2c or c or d. It doesn't matter. Both all are the same. Okay. So this then will cancel with the e, then we will get 2y plus 3 equals e to the power 2x plus c, or 2c or d or k, whatever. I'll leave it now for 2c. Okay, now y equals, I'll move the 3 to the other side, so it becomes minus 3. So it's going to be e to the power 2x plus 2c divided by 2 here, and this is minus 3. Okay? Right. So that's what we get actually here in the question. This in the lecture, he just call it C as instead of saying 2C because it's constant, so it doesn't matter. Yeah, if it's 2C or just C. So if you want, just write it C or D, doesn't matter. Just the capital C, same thing. So that's how we get the Y. Any question about this? Any question about this? No?
No.
Okay. Right. Right. Next example here. We have the acceleration of a car is given by A equals dv over dt equals minus 1 over 4 v squared. So again, and we have this is v equals 5 when t equals 0. This condition here, we don't need it until we finish at the end. Okay, so after you find the general solution, then you can substitute the values of v and t to find the equation for the velocity. All right. So again here, first of all, we need to get rid, we need to separate the terms. So we can divide by v squared here. And this is going to be here, next slide, yeah. Right, so it's like dividing both sides by v squared. Then we get 1 over v squared dv equals minus quarter dt. So what we did here, we divided by v squared and multiplied both sides by dt. Okay, so now I have the v's and the dt in different sides. We do the integration. So the integration of 1 over v squared dv equals the integration of minus quarter dt. Right? Now, 1 over v squared, we can write, when we integrate this, it's the integration of this 1 over v squared, yeah, is v to the, well, basically it means v integration of v to the power minus 2 dv, which means v to the power minus 2 plus 1, yeah, which is minus 1 divided by minus 1. So that's why we get minus v to the power minus 1, which is here, right? So equals minus 1 quarter, and the integration of dt is t, so it's minus quarter t plus c. This is the constant of integration. Right. Any questions so far? No? All right. Right. Now, move here. What we have minus v to the power minus 1 equals minus quarter t plus c. Right, v to the power minus 1 means 1 over v, yes? So if 1 over v equals minus 1 over 4t plus c, then it's like flipping over, okay? This becomes v, instead of v to the power minus 1, it's v, and it's like flipping over this one. It's t to the over 4 plus c to the power minus 1. I'll try to show you here. So this like, it was 1 over v, minus 1 over v it was, equals minus 1 over 4, well, let's make it t here, plus c. So now, if we want to make it as a v, so we will flip this over. So v equals 1 over this, yeah? So like this term divided by 1. So v will be 1 over this term. So it's minus 3 over 4 plus c to the power minus 1. And because we have minus here and minus here, so this becomes plus. So that's why we get v equals q over 4 plus c to the power minus 1. Okay, so this is the general form. And now, because we have the values of t and v, we substitute the values here in this equation. So this is going to be, the v is 5, so this is the v here, equals t over 4, t is 0, divided by 4 is 0, plus c to the power minus 1. So 1 over c equals 5, and therefore c equals 1 over 5. So this is the value of c, and then we substitute it in the general form, and therefore the specific solution here is going to be v equals t over 4 plus 1 over 5, that's instead of the c, all to the power minus 1. And that's it. So this is the specific solution, and this one here is the general. Okay? Yes or no?
Okay, Miss.
Okay. Thank you. Oops. Any question, Abdulwafi?
No, I'm taking notes right now.
Right. Yeah. As I said, it's in the VLE, it's the same slides. It's the topic, it's 19, I think it's old. Right. Let's see here. This is notes for you as well to know. Sometimes, like often you will get solutions of the form y equals e to the power fx plus c. So both of them is raised to the power as a power of e. So in this case, e to the power f of x plus c is like you can write it as e to the power f of x multiplied by e to the power c. Okay? So in these cases, it's usually useful to rewrite the integration constant in a particular way, like this, right? Using the index rule. And because, excuse me, because c is a constant, so we can refer a letter to e to the power c as a or k, yeah? Any letter. So they call it here a, so therefore equals a e to the power f of x, where a is e to the power c is the new way of writing the integration constant. So if we have e to the power c, which is the integration constant, you can write it as a instead of e to the power c as a constant. And then, yeah, so this is just a note for you, like if you get, and like if you solve any question and you reach this stage, or in your solution you have e to the power f of x plus c, you need to change it to this format, and you write your final answer as a e to the power f of x. Right, there is an example here. So dy over dx equals y, given y equals 5 when x equals 0. Yeah, so again, after you solve this, you will find y equals e to the power x plus c, and you need to write it down as e to the power x multiplied by e to the power c, and you will end up with a e to the power x. So your final answer is going to be y equals a to the power a e to the power x. Okay. Now, so this is the general here, y equals e to the power x. Then to find the specific, you need to substitute the values of the y and the x, and y here is 5 and the x is 0. So 5 equals a e to the power 0. So a is 5 because e to the power 0 is 1. So therefore, the value of a, which is the constant, equals 5. Then you rewrite your equation as y equals 5e to the power x, because it was a e to the power x, it was a e to the power x. So now we know the value of a as 5, therefore it is 5e to the power x. Okay? Happy? Right. Hopefully. Can you try do this for me? Give you 2-3 minutes. Yeah, 3 minutes for this. Try to solve this for me. When the first one finished, just say I finished. Yeah, I'm counting now. 3 minutes. I have Imran, Anfal, Sarah, Franciscus, Abdurrahman, Kauthar. Good. Who else? Ali Dabi, Isam, Abdulwafi, Abdullah. Good. Welcome all. Two minutes left. Come on. Are you working? Please, yes. Are you managing, guys? Are you okay with this?
Miss, can you show the way?
Show you what? Sorry. Well, you're sending me messages on the chat. I don't know how to go to them, right? But don't worry. I'll just go through this question. Yeah? Abdullah Nasrallah, have you managed to do anything? Ali Dabi. How are you, Ali Dabi? It's a long time. Franciscus, have you managed to solve?
Good, thank you. How are you?
I'm
I'm
still
all right.
working for it.
How are you, Ali? You okay?
Yes, thank you.
Good. Have you solved the question? it looks like Imran, he did it. Who else? Qatar, Anfal, Abdullah Nasrallah. It's only Abdullah Nasrallah here, so I don't need to say Nasrallah. Okay, so I'm going to do it now, and if you did it, you can just check your work anyway. So what we have here, dy over dx equals 2xy. So we have x and y together. We need to separate them. So first of all, we can divide by, let's go there. Yeah, we can divide by y. So dy over dx equals 2xy. Right, so if we divide by y and move this x dx to this side, so this is going to be dy over y equals 2x dx. So now I have the y's on one side and the x's on the other side. So this becomes, what we integrate them, yeah? So 1 over y, and it's like integration of 1 over y dy, which is ln y, yes? So this becomes ln y equals 2x squared divided by 2 plus c. And we cancel these, oopsie, cancel these, there's some error here. 2x squared divided by 2 of those cancel it now. So then y equals x squared plus c. Right. So now I need y. I want the equation in terms of y. So this is going to be e to the power ln y equals e to the power x squared plus c. So take e for both sides, or you can follow the definition. So this is going to be y equals e to the power x squared plus c. And as we said earlier, e to the power c, we can write it, we can write it as e to the power x squared multiplied by e to the power c. So y equals e to the power x squared multiplied by e to the power c. And e to the power c, we can call it a. So therefore, y equals a e to the power x squared. This is the general solution. So they ask us for a general solution, or and then they give us the value where y equals 3 and x equals 0. So this is the general here. Then when y equals 3 and x equals 0, was it? Yes. Okay. Yes. Therefore, we substitute the values of y and x. So this is going to be to find the value of the constant of a, basically. So this is going to be 3 equals a e to the power, well, 0 squared is 0, and e to the power 0 is 1. Therefore, it's a equals 3. Okay. And
Miss,
yes.
I solved it differently. I didn't use the ln. I just integrated the y to the power minus 1, and later on I got c equals 3 as well.
Which step? Can you write? I think you can write on the board. Just try.
Oh, let me see. I can send it later, but can we use another method or just this one?
What do you mean?
Or they will ask us in the exam that
No,
specific.
if they ask you to use differential equations, you have to use this method.
Ah,
Yeah.
okay.
And usually you will see like the question, it has a mix of dy over dx and the x and the y. So you need to solve it this way.
Okay.
What you can do, I mean, I think you can do a bit different maybe in these steps here. Yeah.
Yeah, I didn't use the ln. Why? I just integrated the dy over y
And
and
how you
become.
integrate it? Dy over y is ln y.
No, I didn't use the ln.
Okay, send it to me and I'll have it.
Okay, later. Thank you.
If you have y to the power minus 1, you can't do that because it ends up as ln anyway. If you have, like, if you make it like y to the power minus 1 dy, it's like when we did before x to the power minus 1 dx. So it's end up as ln. So you can't integrate it differently. You can't say h minus 1 plus 1. No.
Okay.
Okay.
Thank you.
You're welcome. Right. Where we are here. So we'll finish this question here. Okay. We have the next question. So that's the solution for it anyway. I solved it in red. It is here anyway. I don't know if they showed all the steps.
Miss?
Sorry?
Hello, Miss.
Hello, how are you?
I'm good. Miss, are you going to save the screen?
Oh, is that
for
Farah?
later?
How are you, Farah? Sorry,
I'm good. Sorry?
Sorry.
Are you going to save the video?
I don't know if there will be a video. I didn't do a video for this lesson, but
No, like you're gonna keep this lesson.
I'll check later on. I did a record, but not from the beginning, so because I forgot about it, and I will see if it's going to be recorded as we want or not. If it is, I will send it, of course. Yeah.
Okay.
Can you follow up with me or not?
Yeah, I am.
Okay, good. How are you anyway?
I'm good. How are you?
I'm all right. Thank you. Are you in Kuwait?
No, not yet.
Not yet. Woo! Are you in UK?
Yeah, still.
Oh, okay. Right. So stay home. Stay safe.
Inshallah. Even you, Miss.
Thank you. Right. So the next question here. Okay. Just if you try. I mean, because I'm just showing this question, I didn't notice the answers on the next page, and I've been asking you to solve it. Right. But can you try to solve this yourself as well, please? This one. So we have y cosine x. So this is a mixture between an x and y. We need to separate. And what we need, we have dy over dx. So the dy, and we want basically the dy and the dx to be both in numerators. So that's why we decide which one goes where. So the dy on the left side, it's dy on the numerator, that's fine. The dx at the denominator at the bottom, so we move it to the other side to becomes at the top. So this is going to be, so I have y here, I will divide by this lovely y. So this becomes dy over y equals cosine x dx. So far happy? Yes, I hope so. And now we will integrate this. Yeah, so we do the integration of dy over y equals integration of the cosine x dx. So integration of 1 over y basically is ln y. So ln y equals the integration of the cosine, if you remember it, is sine x. If you don't remember, I hope that what I put before in the other video, you write them in order, sine x cosine x minus sine x minus cosine x and sine x. And we go from the bottom to the top. So we want the integration of the cosine. So this is the integration here. Integration of cosine is the one above, which is sine x. Yeah, this is just to remind you of it. So this is going to be sine x plus c. Why plus c? Because it's indefinite integration. Yeah. Yes. Now I have ln y equals sine x plus c. I want to find y only. So I will take e to the power both of them. Or you can use the definition, you know the definition? Ln, it means the base is e. So e to the power of this gives you this, the y. You can use any of them. Both are the same. Okay, just move a bit. Right, so y equals e to the power sine x, let's go here, plus c. So this means e to the power sine x, multiplied by e to the power c, and e to the power c can call letter a as a constant. So y equals a e to the power sine x. This is the general form. This is the general one. Right. What general solution? Oh, no. Sometimes I think general solution. Okay. Did they give us a specific values to substitute? Yeah, y7x0, y7x0. So we just substitute now the value. So y7x equals 0. Then 7 equals a e to the power sine 0. You remember sine wave here, like this. So sine 0 is 0. Sine 0 equals 0. So e to the power 0. 7 equals a e to the power 0, which e to the power 0 is 1. So 7 equals 8. And therefore, the constant is 7. So we can write the equation as y equals a e to the power sine x. This is as a specific point. And that's it. Is that okay? Have you got that?
Yeah, can I look at from the beginning?
Yes, you can.
Miss, what's the difference between the first one and the last one? The specific and general.
The general is it's in terms of x and y, and the constant as a, or e to the power c. But when it's specific, you get 7 instead of the a. So you basically just substitute the value of a, of the constant.
Because down you put a, not 7.
Am I? Because me, you know me.
Okay.
Sorry. Thank you. Thank you, Abdulrahman. Did I say A or 7? Right. Thank you very much. Well done. Yeah, that's what it is. I don't think this is a good video to put somewhere.
No, it's fine. I'll send it for me privately. It's fine. I don't mind.
All right. Franciscus, is that what you thought from the beginning? Or do you want the slide as well?
I just want the answer.
No, I just want the answer. There you go. The mini version. I will do some questions for you as well. Right. Where does it look? I think page you have a lovely book. So you have exercise 12.2, page 363. And so when you work out, you can check your answers on page 539. I'll do some questions for you. Okay. So not this. Right. So we have exercise 12.2, page 363. And the answers, if you want to check your answers as well, page 539. Okay. Right, so I will do question 1A. Question 1A. Question 1A, saying find the general solution. Find general solution of the following differential equations where x more than 0. Give your answer in the form y equals f of x. So it's dy over dx equals 8x cubed. So what we need to do first, Farah? Separate x and y's, yes? All right. So I have only
Divide
the
by
x. Sorry?
Divide by 8.
We don't need to divide here because
dy equals to 8x cubed times dx, isn't it?
yes, that's right. So we don't need to divide here because we have the dy at the top here by itself, and we have 8x cubed on this side, and it doesn't have any dx, right? So in this case, all we need to do is multiply, if you want to say it in this way, multiply both sides by dx, okay? So if you multiply both sides by dx, that means it's going to be, yeah, it's like there's going to be dx here times dy over dx. So we'll get rid of the dx's from this side, equals 8x cubed dx, right? So now we have the integration of dy equals integration of 8x cubed dx. The integration of dy is y, and integration of 8x cubed, it's you add 1 to the power, so this is going to be 8x to the power 4, divide by the new power, which is 4. Then you simplify by 4. Oops, sorry, by 4 is 1. 4 is 1. And by 4 is 2 here. And plus c. Don't forget the c. There's one more I think it's not c. If you forget the c, be careful. Right. So y equals 2x to the power 4. 2x to the power 4 plus c. So this is general form, general solution in terms of x and y plus excuse me, plus c. So that's it. They didn't give us the value of x and y, so that's what it is. That's the general solution. So for you to do, you can do BCD. Yes, you can do BCD. And I will do, question E for you. Okay, just I'll give you time to do B for me now. Okay, and while I'll prepare E myself and solve it for you. Okay.
Miss, can you say again which question?
Question 1, page 363. Do B, C, D. So for now, just do B. And I will do E now, and I'll explain it for you as well. Okay, I did A. I'll give you some more time. I will do F as well for you. But I need to work it out. It's a bit hard, this one. Actually, I might leave it to another time. Okay, I will leave F for now. I will do it later, maybe. Because F, you need to do what is it, partial fractions with it as well. If I do this, right. I'll do E for you. Question one is the dx minus cosine x equals y cosine x. Okay, so as you can see here, we have minus cosine x on the left side. So we'll move this to the other side. So this is going to be dy over dx equals y cosine x plus cosine x, right? And I can take cosine x as a common. So dy over dx equals cosine x y plus 1. Right. So now, as you can see, I have this like y and this as x. So we need to separate x and y. So we will have it as like multiply both sides by dx. So I will have dx here. So this is going to be dy over y plus 1. Yeah, so we divide by y plus 1 both sides. So get dy over y plus 1 equals cosine x dx. So now they are separated. Therefore, not very comfortable to write on the laptop. Right. So we'll do the integration. So this is going to be ln y plus 1. So ln y plus 1 equals, what's the integration of cosine? Yeah, remember here, if it's sine and cosine, then the integration of the cosine is sine. So this is sine x plus c, right? Now, as the previous question, or one of the questions we did, to get rid of the ln, we do e to the power. You can either use the definition or you take e for both sides. Yeah, so e to the power ln y plus 1 equals e to the power sine x plus c. And this means y plus 1 equals e to the power sine x plus c. And e to the power sine x plus c can be written as e to the power sine x multiplied by e to the power c. And this e to the power c can be written as a. Yeah? So y equals a e to the power sine x minus 1. Wait a second here. Is there undo here? Yes, undo, undo again, undo again, undo, undo. Yeah. Okay. E to the power sine x minus 1 down there. So that was plus 1 here. So we'll move it to the other side. So that's why it's minus 1. So this is the general solution.
Miss, I have a question. How did you find y plus 1?
How did I find? It was dy over y plus 1. And y plus 1, the integration for dy over y plus 1 becomes ln y plus 1. And to get rid of the ln, I took e for both sides. Yeah, so e to the power ln cancel with the e. So I end up with y plus 1.
Yeah, sorry, I was looking at a different question.
That's fine. Okay, so that was E, question 1E. Right, so I want you to do, as I said, B, C, D. I did E for you, and I will do F as well. It's a bit, also, let's see. If you, yeah, I will leave you a little bit to do B, C, and D, and I will do F for you and find some other question maybe for you. Okay? Happy? So I'll just yeah.
Miss, which questions are we supposed to do now?
Question 1, B, C, D.
Okay.
Okay, and I'm doing F for you now. Okay, guys, I will do question 1F. The question 1F is find the general solution. Okay, so the question is, this is F here. The question is dy over dx equals, just check this, 3x minus 6y over is 3xy minus 6y over x minus 4 times 2x minus 5. Okay. Can you hear me? Clear?
Yeah.
Yes.
Okay, good. So, first of all, here we have 3xy minus 6y. We can take a 3y as a common from here and write it down like dy over dx equals 3y as common. So left with x minus 6 here divided by x minus 4 and 2x minus 5. Right. So I have mostly on the right is the axis, but it has a 3y in it. So I will divide by 3y both sides to get rid of the 3y from the right. Okay, and I will put the dx, multiply by dx for both sides as well. So I will have dy over 3y, okay. Do you want me to move the dx now? Yes. Equals x minus 6. So is it x minus 6 or minus 2 actually? Sorry, because we took the 3 out. Yes, it's minus 2. X minus 2 here. Right, over x minus 4 times 2x minus 5 dx. Right. So in this case here, we have a partial fraction, which is x minus 2 over x minus 4, 2x multiplied by 2x minus 5. It's not very easy to solve this kind of question in integration. We need to deal with it with what we learned before, partial fraction, if you remember, or you should remember, we did that in the exam anyway. Okay, the one with the a and b. So for now, we will stop from carrying on in this question. We'll do the part of the partial fraction. Yeah, so I have x minus 2 over x minus 4 times 2x minus 5. Yeah, here is partial fraction. Partial fractions. And because we have two terms down there, it's going to be a over x minus 4 plus b over 2x minus 5. And now we need to solve this first, and then we'll carry on the integration. So this is going to be, well, the denominator basically, it's going to be x minus 4 times 2x minus 5. I told you before, it's same as what's in this side anyway. Okay, so this is going to be a times 2x minus 5 plus b times b plus b times x minus 4. Right? I have to do it. Yes. So that's equal this side here, x minus 2 over x minus 4 to x minus 5. We did this before anyway, so I hope that you remember it. So now that means we can equate the numerators together. So therefore, x minus 2 equals a 2x minus 5 plus b times x minus 4. So now we are looking at the value for x to make it equal to find the a and b. So we need the value of x that makes it 0 inside the bracket. So let's say x equals 4. So when x equals 4, then this becomes 4 minus 2 here. 4 minus 2 is 2. Yeah, equals a times, well, basically there's going to be 8 minus 5, which is a 3. So there's going to be 3a plus 0. And therefore, a equals 2 over 3. Okay, so that's a. And now we need to find b. So we make a equals 5 over 2. So when x equals 5 over 2, then we will get 5. It's like 5 over 2 minus 2 equals 0 plus b times 5 over 2 minus 4. This is just for you. And therefore, there's going to be 1/2 equals 5 over 2 minus 4. 5 over 2 means 2.5. Minus 4 is minus 1.5. Minus 1.5 means minus 3 over 2. Yeah? That's minus 3 over 2b. Therefore, b equals, again, I'm going to do it in very detailed q, means 1/2 over minus 3 over 2. And that becomes 1/2 times minus 2 over 3. Cancel these and you end up with minus 1 over 3. So b is minus 1 over 3. Okay. Now, so we got a and b. We can put them back in the integration. What is the word integration? Yeah. So I'll substitute the values of a and b here instead of a and b in the green color. Actually in our integration. So now I'll just write it again. So what we were up to dy. I'll just write this again. We were at dy over 3y equals x minus 2 over x minus 4 to x minus 5. That's where we stopped and we started to find the a and b. So now we know this is a, which is 5 over 2. So this becomes 5 over 2 over x minus 4. And because this is minus 1/3, so I will write it as minus 1 over 3 over 2x minus 5. Okay, so that's dy over 3y equals this. I'm just
Miss,
gonna, yes?
I think it's not 5 over 2, it's 2 over 3 for A.
Yes, you're right. Wallahi, you're right. Thank you, Abdullah.
Welcome.
Did I write it wrong somewhere else as well?
No, only here.
Only here. Okay. It's 2 over 3 over x minus 4 minus 1/3 over 2x minus 5 dx. Okay, so I'll put the dx like that. this, integration with this, dx. Okay? So, dy over 3y, we can take the 1/3 outside. So this becomes like 1/3, and the integration for dy over y is ln y. Are you okay with this step? I just put the 1/3 outside the integration, and the integral of dy over y is ln y equals, what is it here? So 2/3 and 1/3, again, it's like I can write them 2/3 and 1/3. So I'll take the 1/3 outside. So it's like taking the 1/3 outside and leaving the integration of 2 over x minus 4 minus 1 over 2x minus 5 dx. Are you okay up to here? Hope so. Right. So
Yeah, all right.
what we can do, we can cancel these 1/3 from both sides. We don't need it. So in this case, it's going to be ln y equals, right, for this one, it's going to be 2 ln x minus 4 minus, I can take the half outside here, so it's minus half ln x minus 5 plus c. And c here, because our answer was ln y equals, so because we are dealing with lns, we can say we call the ln c as ln d. Okay, so we call this as ln d. It's a constant, but in ln format, just to be able to deal with it. So, where we are now. Oh, yes, therefore, ln y equals what? Equals, it's a bit confusing, huh? Ln y equals where I have this 2 ln, so okay, so this highlighters is not clear. I don't like them. So I can put this as a power for the ln, and I can put this half as a power for the ln. Yeah, so this will be equal to then right. So which one? Yeah, the first one here, the 2 ln x minus 4, it's going to become ln x minus 4 to the power 2. X minus 4 to the power 2. Okay, and because there is minus here, that means it's a division. Yeah, for x minus 5 to the power half. Okay, and this lovely ln need to be in the middle, not on the line really, because it's like ln minus ln. Yeah, so it's ln here, x minus 4 squared, and because there is a plus c, which is plus ln d, so when we do plus, that means multiplied, so we can do here times, yeah, multiplied by d, undo again, yes, multiply by d, that's 2x minus 5 Yeah, sorry, this is 2x, not x. This is 2x here. Put as a stop that now. Then 2x minus 5, and this will be 2x minus 5.
So we do half in the front of ln 2x minus 5, or
So we do
just-
have 5 half, and I just figure out when I did this, I figure out I think I did a small mistake at the top. I will go back to it. Just remind me, huh? 2x minus 5 to the power half here is then 2x minus 5 plus yes. Yes, we still have the half because we have originally 1 over 2x minus 5. Yeah. So to get to apply like f prime x over f of x, the integration, we need the derivative for 2x minus 5. And the derivative for it is 2. Because we don't have 2, yeah, so it's like we are saying, okay, we multiply by 2 and we divide by 2. So that's why we do the half. Yeah, it won't really affect. So this part here, the 2 over 2x minus 5, you can write it as ln 2x minus 5. And this multiplied by half. I think I explained this a little bit wrong. At the top, I put another 2, which is wrong. Yeah, that's what it meant. So you can do it either 2 ways. Either this way, where to follow this formula, we need the derivative of the denominator of the bottom, which is in this case is 2. You can't just put 2, so we need to multiply by 2 and divide by 2, and that's how we got the 1/2. Or you can just write it as ln 2x minus 5, and you divide by the derivative of the x, yeah, which is 2. And yeah, ln 2x minus 5 divided by the derivative of the 2x, which is 2. So, which is exactly same as this. These are 2 ways. I did it a bit wrong at the top. I will go back and correct that. Let's just finish this question. Any question about this step? Farah, Abdullah, Ali Dabi, Isam. Are you okay, Isam?
Yeah.
Good. Okay. You okay now, Franciscus, with this step?
I'm
No?
not really sure about it.
Okay. Do you want me to go through it again?
Yeah, if you want to.
Okay. Oh, remove the half and remove the 2. Okay. So if you want to follow this f prime x, and battery low, not the time, not the strong time. Okay, f prime x over f of x. Yeah. What is it? Yeah. So what's the derivative of 2x minus 5 is 2. So I'll write it in red. The derivative for 2x minus 5 is 2. And because we can't just put 2 from nowhere, we need to divide by 2, yeah, to balance it. It's like multiplying by 1. So we multiply by 1/2. So this bit now, when we have 2 times something, I mean 2 over 2x minus 5, this is, we can call this as ln 2x minus 5, because we have the function and we have the derivative. So far, so good?
Okay.
Yeah, and we have the red half here outside. So that's what it is.
Okay.
So that's one way. The other way, maybe it's easier if you want to think about it, is because you have it 1 over 2x minus 5, then you can write it as ln 2x minus 5, and then you divide by the derivative of 2x, which is 2. So it's like 1/2 ln 2x minus 5. Same thing.
Okay.
Okay?
Okay.
Right. Take this off. No, I end up with circles. Nice one. I don't know. Right. So the pen batteries, the charging is low. I think I need to put the laptop to carry on, but hopefully we'll finish this question before it dies. Right. So ln y equals ln this over that. Therefore, I can get rid of these lovely ln's. Huh? So I end up with y equals x minus 4 squared multiplied by lovely d and divided by 2x minus 5 to the power half, yani root 2x minus 5, and that's it. Okay, happy. This is the general solution for it. I want to do question 2 for you as well. What time is it? Do you still have time? 10 minutes. Okay.
Miss, can we take it as homework?
Who's that? Abdullah.
Yes,
Oh my God, clever.
I am happy.
Are you happy? Hatta even on online until you get
Yeah, me
bothered
too.
from the lesson. Oh my God.
Because I was working all the class, so
Well done. Are
I
you
didn't
happy?
talk.
Okay. Okay, then I will give it to you homework, or maybe I will work it out and send it to you. Maybe we'll see. I'll take a picture and send it to you. Maybe. Anyway, I'll find out, because I thought like I explained the steps, if that will helpful. So before you go, before you be very happy and you go, how was this lesson? Because this is really the first lesson I do online live with Zoom and in anything else, and I just decided to start with your group. I feel more comfortable with your group to do it. Even if I get any mistake, it's fine. So feedback, what do you think? Was it the sound, the voice? Can you follow me? Easy? Is there any delay when I write?
We follow you. We follow you when you write yourself better than when you read, I think.
Yes, of course. Yeah, that's why sometimes I use the highlighter to highlight what I'm saying. Yeah, I understand that. Yeah. But when I write, is there any delay?
It
Sometimes
shows
due to internet connection,
after all.
maybe.
Sorry, what about the connection?
Maybe due to the connection. If the connection was good, there are no delay.
Right. Okay, that's fine. So that's good. I think that's the end of today's lesson. I hope you learned something, or you're happy. As I said, I'm going to do question 2 for you and send it to you maybe. Question 2, F and A and F. Okay, I will do A and F, and you feel free to do anything in between. Question 2.
Okay.
Right? And
Yes.
those, I'll see you all. I might see you tomorrow. Right?
Do we have a class?
I don't know. I need to look at the timetable. If I have, that will be great. Do you want it to be like this, live?
Yes.
Right. Okay, then. I'll see
Miss,
you
I have
tomorrow.
also a question. How will the test be? Is it gonna be open book or how?
Oh, if you open your book, if you don't open your book, who
I
can
don't
see
know,
you?
because the physics they told it's open book.
It's in a way, it's a nice way. I don't know. It's an online one. Open book or you don't open book, I don't know exactly yet. So you know me, I don't want to say things which I'm not very sure, but it's going to be online in a way. We will do a mock for you as well.
Okay.
A mock test, so you need to be attending the class really during the
When
class.
is the mock test?
When is
Is
the
it
mock test?
On May or before?
Yeah,
maybe before?
your exam in May, I think something 4th of May or something like that. Something like that. I just forget, we were in a meeting yesterday. I said. So you will have mock tests maybe next week. I'm not sure. Again, when they will decide, I will let you know, because they need to set the format for it on the VLE.
Okay.
Okay. But until we do that, I think these live sessions, it's good to explain things for you. Tomorrow, maybe I'll go through a partial fraction integration, some more exercises for you. I'll explain.
Okay.
Okay. So, wish you all the best. Stay home, stay safe, stay isolated, and if you're happy and you know it, you can go.
And go.
Thank you very much, everyone.
Thank you so much, Miss, for
Thank you.
Bye.
Thank you, Miss.
Bye.